In a noteworthy declaration that could change our situation in the universe, NASA has detailed the location of the first extraterrestrial signs coming from the direction of Proxima B, the nearest known exoplanet to Earth, found just over 4 light-years away in the habitable zone of its star, Proxima Centauri. This revelation has generated a wave of excitement and interest worldwide. Could this be the moment when humankind discovers that it is not alone in the universe? The path to this earth-shattering revelation began with careful observation by NASA's powerful telescopes, which have been monitoring distant stars and planets for signs of activity. Proxima B has always been a top candidate in the search for extraterrestrial intelligence due to its Earth-like qualities and its proximity to our own solar system. The signal detected is unmistakable and unlike anything astronomers have ever observed, marking a potential turning point in human history. The implications of such a revelation are significant. First, it confirms the long-held scientific hypothesis that life could exist on other planets under Earth-like conditions. Second, and perhaps more intriguingly, it raises questions about the nature of the civilizations that might inhabit these planets. Would they be simple microorganisms or advanced beings capable of interstellar communication and travel? This signal from Proxima B is not just random noise or a natural cosmic phenomenon. It carries a structured repetition that suggests an intelligent origin. NASA scientists, along with international teams, are now tasked with deciphering this message, trying to understand its content and the intentions behind it. The global academic community is abuzz with hypotheses and theories about the possible nature of this message. An invitation, a greeting, a warning, or something completely beyond our imagination. News of this discovery has spread beyond the scientific community, igniting debates on social media, in government rooms, and around dinner tables all over the world. People are looking up at the stars with renewed wonder, contemplating beings who might be doing the same on a distant world. How similar or different could their world be to our own? What might their society look like in terms of technology and culture? These possibilities seem as vast as the universe itself. Furthermore, this detection raises numerous moral and existential questions. How should humankind respond if the signals truly come from intelligent beings trying to communicate? What protocol should we establish for interstellar diplomacy? And most importantly, how might such a discovery change our understanding of religion, life, and our very identity as humans? While excitement is growing, there is also a tangible caution. Scientists at NASA and other space agencies are working tirelessly to validate these findings. It is not a stretch to say that the signal, whether positive or a distortion, could bring us to the brink of the most significant revelation in human history. Therefore, the next steps must be taken with precision and responsibility. The world waits eagerly for more detailed analysis. The detection of alien signals from Proxima B not only advances our scientific efforts into a new era, but also unites us with a sense of curiosity and hope. We could finally be on the verge of answering one of the oldest and most profound questions. Are we alone in the universe? In April 2019, a radio transmission was detected coming from space, specifically from the Proxima Centauri region, 4.37 light-years away from us. Although it may seem a significant distance, it is the closest star to the Sun, being multiple times farther away than the third brightest star in our sky. The signal comes from a triple star system composed of the binary pairs Alpha Centauri A and B and Alpha Centauri C, also known as Proxima Centauri. Alpha Centauri A and B, the two stellar companions, are relatively close to each other and very similar to the Sun. Alpha Centauri A shines with a yellow light and is 1.5 times brighter than the Sun, while Alpha Centauri B is half as bright with an orange hue. Alpha Centauri A is slightly larger than our Sun, and Alpha Centauri B is slightly smaller, so our Sun fits exactly between them in size. But where did the signal between these two stars come from? The Breakthrough Listen project, dedicated to searching for extraterrestrial communication in the universe, has named the Signal Breakthrough Listen Candidate 1, BLC-1. The project, with around $100 million in funding, has utilized years of observation with advanced telescopes around the world. The signal was detected by the Parkes Radio Telescope in New South Wales, Australia. This telescope was observing the region of Proxima Centauri, the closest star to our Sun. This signal almost went unnoticed among the massive volumes of data collected over years, but the scientists managed to identify it like a needle in a haystack. For the signal to be considered significant, it must have two clear characteristics. First, it must be narrow in frequency range since such radio transmissions are not created by natural elements in space. Second, the frequency must fluctuate according to the relative motion of the exoplanet concerning Earth. The scientists had to examine nearly 4 million individual signals captured by the telescope in Australia. After an exhaustive process of filtering and eliminating unnecessary signals, they found 5,000 distinct signals, among which one stood out, a signal that could not be explained after cross-checking with contemporary radio transmitters on Earth. This unique signal with a narrowband technological signature only appeared when the telescope was pointed towards Proxima Centauri and was observed over a 30-hour period. Upon further examination, it was determined to be Proxima B, an exoplanet discovered by astronomers in 2016 using the radial velocity method, which detects variations in a star's position caused by the gravitational pull of orbiting planets. The star will describe a small circle, and extremely sensitive spectrographs are used by experts to track the light from a star. The spectrum of light shifts slightly towards blue as it moves away from it. When these shifts occur repeatedly in regular patterns over days, months, or years, it is accepted that the variation in light is caused by the gravitational pull of an orbiting planet. On closer inspection, Proxima B turns out to be very similar to Earth, with a radius 1.1 times that of Earth and a mass 1.3 times that of Earth, indicating that it is a rocky world with similar density. However, there are significant differences. The first is the location of the two planets in their respective solar systems. Proxima B is much closer to its parent star at only 0.05 astronomical units, while Mercury is at a distance of 0.39 astronomical units from the Sun. This proximity would cause Proxima B to be an extremely hot planet, but because Proxima Centauri is a dim red dwarf, the planet receives only 60% of the energy that the Earth gets from the Sun, putting it in the habitable zone where life could exist. There are countless unknown planets scattered throughout our universe. So far, we have discovered an impressive 4,935 exoplanets and have recently added 65 new planets to our count, bringing the total to 5,000 planets. This latest group of 65 exoplanets was added to NASA's Exoplanet Archive on March 21st of this year, marking a milestone in planetary exploration. The James Webb Space Telescope, JWST, is the most advanced telescope ever built, being multiple times more powerful than its predecessor. With its help, we will be able to unlock the secrets of the vast stretches of the universe. In the past, we have discovered a wide variety of planets, from small rocky worlds to gas giants larger than Jupiter, as well as extremely hot planets and habitable ones. Among these discoveries, a few planets stand out. Kepler 1649c is one of those planets whose characteristics are very similar to Earth. In fact, it is the most habitable planet we have found so far and could harbor life. So far, we have identified 55 Earth-like planets, but we have not yet been able to study all of them in detail. With the rapid advancement of our technology, especially due to the James Webb Space Telescope, who knows what more we will be able to achieve in the future. Wouldn't it be amazing to find a planet capable of supporting life? One of the main goals of the James Webb Space Telescope during its first year of science missions is to find and study extraterrestrial worlds beyond our own solar system, focusing on how they form and the likelihood that they can contain water and organic life. Webb's research on star and planet formation allows us to link studies of mature exoplanets to their birth conditions and connect our own solar system to their origins. Webb's infrared capabilities are ideal for uncovering how stars and planets form for three exceptional reasons. Infrared light penetrates dust well, detects the thermal signatures of young stars and planets, and indicates the presence of key chemical components such as water and organic compounds. Mid-infrared light can pass through clouds that are multiple times denser than visible light, which is particularly important when observing newborn stars hidden within their natal clouds. These infrared capabilities are crucial because they allow us to observe and capture the early stages of star formation when gas and dust are still contracting to give birth to young stars. However, there is more to the natal clouds of stars than that. Both young stars and giant planets start as large, bloated structures that gradually contract over time. As newborn stars get hotter as they age, giant planets cool, but both emit more light in the infrared spectrum than at visible wavelengths. This means that the Webb telescope will be excellent for finding new stars and planets and helping to understand the physics of their formation. With its MIRI instrument, Webb will also search for hot molecular gas near various young stars, which could indicate the formation of potentially habitable rocky planets. Unsurprisingly, much of the James Webb Space Telescope's early science work will focus on determining how planetary systems build molecules that may be crucial to the formation of life. The search for extraterrestrial life has long captured the imagination of humanity, fueling scientific inquiry and speculative fiction alike. The recent detection of unusual radio signals from Proxima B has reignited the debate over the existence of intelligent life beyond our solar system. While definitive proof of extraterrestrial intelligence remains elusive, the scientific community continues to explore this intriguing possibility with advanced technologies and rigorous methodologies. The search for extraterrestrial life not only pushes the boundaries of our scientific knowledge, but also challenges our understanding of our place in the universe. Whether we ultimately discover alien civilizations or not, the quest for answers to this profound question continues to inspire and drive the progress of science and technology.